Hello everyone. We will now begin our lecture on section 2 of chapter 3, which is on truth tables for negation, conjunction and disjunction. Now, truth tables are actually logical tables that help us determine whether a certain statement is true or false. And we start off with simple constructs. We start off with truth tables for simple statements, and then we will see how we can extend that to compound statements involving the not, the and, the or, and later on the conditional and biconditional constructs. So these are some of the topics that we will cover in this section. First of all, we will understand what truth tables are for statements involving negations, which mean the not statements, then conjunctions and statements, and disjunctions are or statements. And then we learn the method of constructing truth tables for compound statements involving negations, conjunctions, and disjunctions. We will also explore alternate methods of constructing truth tables. And finally, we will also learn how to determine the truth value of statements without constructing truth tables. Now, a truth table is used to determine when a compound statement is true or false. So essentially, a truth table will look at the statements involved in a compound statement, and it'll determine whether each of these statements are true or false. And not only whether they are true or false, but also it'll consider all the different cases of true and false of the two statements, and then come to a conclusion whether the compound statement as a whole can be classified as a true statement or a false statement. Now, the first truth table that we will look at is the negation truth table. And this is a fairly simple, straightforward table. If the statement is true in negation, the statement will become a false. And if the initial statement is a false statement, then when we negate it, it will become a true. So the case one, there are two cases. The statement could either be a true statement or a false statement. So if you're negating a true statement, it'll end up being a false. And if it is a false statement to begin with, then when you negate it, it's going to become a true statement, right? Before we go into constructing truth tables for compound statements, we have to consider all possible cases of whether each of these statements can be true or false. All right, and then we will come up with the conclusion whether the entire compound statement is true or false. So when we have when we work with two statements, P and Q in this case, there are four possible cases that can happen. First one is statement 1, that is P is true and Q is true as well. Case 2 is the first statement is true, but the second statement is false. Case 3 is first statement is false, second statement is true, and in case 4, the final case where both statements are false. All right, so we have to know these cases because a truth table has to cover all possible cases that of true and false that the statements can take. So now that we have considered all possible cases of statements being true and false, let's see how the compound statement constructed with the AND construct will result in, all right, for all the different combinations of P and Q being true and false. So over here, we have all four cases listed. So now we've added a third column to the truth table. So we are going to consider each case and decide whether the final result of the compound statement is a true or false. So in case 1, we have the first statement true, the second one is true, both are true, then the result is a true. If the first one is true and the second one is false, then the final result is a false. The first one false, the second one true, results in a false compound statement. And when both the statements are false, then the compound statement is also false. Now, I'm going to give you a quick example of what we mean by putting together two tangible statements that will make more sense, or it'll bring more sense to what we are talking about. So let's say P is the statement the earth, all right, the earth is round. All right, the earth is round, and let's say Q is a statement which says earth has oxygen. Earth has oxygen. And we will connect them with the AND condition. All right. So over here we see the earth is round is a true statement, correct? And the earth has oxygen is also a true statement. So P is, and let me just mark this is a P. This is a P, and this one, just a second, this is P, and the second statement is a Q. All right. So in this case, both P and Q are true. So that makes it a true statement. The earth is round and earth has oxygen, of course. So this is a true statement. What would happen if the first one was a true? So I would keep this as the earth is round and say earth does not have oxygen. So let's change this and write earth has no oxygen. I'm going to negate Q. All right. So earth is round and earth has no oxygen. The first statement is true, but the second statement is false. Correct? The earth does have oxygen. So this second part of the statement is false. So true and false makes this entire statement, compound statement, false. Correct? Okay. Case 3 says the first one is false. So let's change again. The first one is going to say the earth is not round. So let's make that change. Earth is not round. And for Q, it is a true statement. So I'm going to change this no to, or rather I'm going to erase that and make the second statement true now. So the earth is not round and earth has oxygen. So even though the second statement is true, the first statement is false, therefore this entire compound statement is false. So when in the case of F and T, the final result is a false. And then finally in case 4, when both are false, so the earth is not round and earth has no oxygen, both are false, therefore the result is a false. All right. So the conjunction is true only when both P and Q are true. Otherwise, all the other combinations result in a false statement. We now look at a truth table for disjunctions. Recall that disjunctions are or statements. All right, so they are or statements. So there are two statements connected with an or. So first let's study the truth table given to us, and then I'll give you an example. So in case 1, when both P and Q, both statements are true, the final result of P or Q is a true. If P is true and Q is false, then the result is still true. If one is false, the first one is false, the other one is true, the result is still true. But if both of them are false, then the final result is a false. All right, the compound statement is false. All right, so we see over here, unlike with the case of conjunction, as long as one of the statements is true, the overall result is a true. Only when both the statements are false, we get a false for the final conclusion, final answer. All right, so to give you an example, let's say you want to go to a restaurant and you make up your mind, or you decide that I'm going to go there and either have soup or salad, nothing else. I will just have soup, so I'll call that P. I will have soup, or Q will be a salad, and the connective here is an or. All right, so this is an or statement. So let's see how the final result turns out. So you go to the restaurant and you ask for a soup or salad. And the waiter says, well, we have both. We have both soup or salad. Which one would you like? So you order one of them and you get your order. Correct? So P or Q in this case, both were available, both were true, soup or salad. Therefore, P or Q is marked as true. What happens if they say, well, we have the soup, but we don't have the salad? So in that case, soup is true, is available, but salad is not available. But even then, you still have something to eat. You still can get your order, right? So the overall conclusion is true. Out of soup or salad, one is available, one is true, therefore the overall result is true. What happens if they say, well, we don't have any soup today, but we have the salad, so I can bring you the salad? That works fine too. So you get your order. So the overall statement is a true as well in this case. But if they say, sorry, we don't have the soup, neither do we have salad today, then you don't get any order, right? You don't get to eat there at all. You have nothing to eat. In that case, the final result is false. All right. So this is a simple example of how the truth table results work for disjunctions. Now the truth table for negation is pretty simple. Recall that negation has the sign or the symbol which is a tilde, correct? And it works with a single statement. It works with a combination of statement as well, if put together within brackets, but that is one group, all right? But otherwise negation will always work with a single statement. And then we can combine that with other conditions. So if we have a statement which is P, and let's say P is a true statement, if we negate that statement, then it'll become a false. If the statement P is false to start with, if we negate that false statement, it'll result in a true. So if the statement is the world is round, which is true, if we negate that, then we'll have to say the world is not round, correct? Negation uses the word not. So if the true statement is the world is round, and you negate that and say the world is not round, then that's a false statement. The world is round and you're saying world is not round. That's not correct. That's false. If we begin with saying that the world is not round, all right, if we say something like the world is flat, all right, let's say instead of saying not round, let's say the world is flat, which is a false statement to begin with, and we negate that and say the world is not flat, then that's true. The world is not flat, the world is round, correct? So that's how the negation works, right? So let's pull up the rest of the information in the slide. It says here, negation symbolized as tilde P is read not P. If P is true, then not P is false, right? Like we said, the world is round. If we negate it, world is not round, then that's a false statement. If P is false, that is, if we say the world is flat and we negate that and say world is not flat, then that is a true statement. What else do we have here? It says, in other words, not P will always have the opposite truth value of P. So as soon as you negate a, a true statement, it'll become false. If you negate a false statement, it'll become true. And now just to summarize what we learned about conjunction, disjunction, negation, and all that. So conjunction symbolized as P and Q is read P and Q. And this statement will be true only when both P and Q are true. All right. So both of them have to be true in order for the compound statement to be true. Otherwise, it will be false. Now, as far as statements involving disjunctions are concerned, which imply P or Q, all right, read as P or Q, the compound statement will be true when either P is true or Q is true or both P and Q are true. In order for the compound statement to be false, then both P and Q should be false. So in other words, P or Q, or represented by the V symbol, would be false only when both P and Q are false. So now we learn how to go about constructing truth tables that involve negation, conjunction, disjunction, and later on we'll extend that to include conditional and biconditional statements. But there's one convention that we need to follow. So the question or the examples that we are going to work through will say, determine if the statement is a negation, conjunction, disjunction, conditional, or biconditional. But however, it goes on to say that we follow a rule that the answer to the truth table appears under this tilde symbol if it is a negation, the downturn V symbol if it is a conjunction, the V symbol if it is a disjunction, which is the or statement, the arrow, all right, the one directional arrow if it is conditional, and the bidirectional arrow if it is biconditional. That's where we will place the final result. All right. So just to give you an idea what we are talking about. So if we have this situation uh, P and Q, all right, and we are trying to determine or construct a truth table for it. And remember, the condition was T and T. If both are true, then the final result will be a true, correct? So that true, the final result is going to be written under the symbol, all right, under the conjunction symbol. So it's going to be true. If P is true and Q is false, the final result will be a false. So that is how we are going to represent our truth table. All right, so that's what they're trying to say here. Now, in the next few slides, they tell us the step-by-step process of constructing truth tables. I'm going to read through them, but I'm not going to spend much time explaining it because we're going to work through an example, and it will probably be more helpful if we explain the steps while going through the example. But I don't want to skip them entirely. I will read through it, and if needed, I will explain some of the steps, but eventually we will work through examples. All right. So it says, as step 2, complete the columns under the simple statements P, Q, R. So in this case, they have 3 statements. They have included a third statement, not just P, Q. So we just fill in all the possible cases that P, Q, R could take, the possible cases of or the possible combinations of true, false, and so on. And if there are any negations present, so you indicated by the tilde P, tilde Q, and tilde R, so not P, not Q, and not R, then we will fill those out as well. And if there are any parentheses present, we will work those first. All right. as well as if there are any nested parentheses. And just like in the order of operations, we will work with the innermost parenthesis first. So in the third step, it says complete the column under the connective, so under that symbol, connective, within the parentheses. So we start with the parentheses if there are any present. If present, you will use the truth values of the connective in determining the final answer in step 5. Then it says after we are done with the parentheses, we must complete the column under any remaining statements and their negation. And we will then complete the column under any remaining connectives. The answer, the final answer, will appear under the column determined in step 1. For conjunction, disjunction, conditional, or biconditional, obtain the value using the last column completed on the left side and on the right side of the connective. If there are negations, negate the values of the last column completed within the grouping symbols on the right of the negation. Circle or highlight the answer column and number the columns in the order they were completed. Here's an example to create a truth table with a negation. We have been given a statement in symbols, all right, a symbolic statement. So we are going to analyze this a little bit, and then we are going to go into constructing the table step by step using the process that we had learned in the previous slides. All right, so let's look into the statement given to us. It starts with a negation, which means not, and then we have a parenthesis, and within the parenthesis there's another negation, and this time it's negating Q. So again, the tilde means not. That's followed by an or, correct? That's a disjunction. And then we have P. So it's not Q or P, and that's all, correct? So it's not, within brackets, not Q or P. So we have to construct a truth table for this. We will start by first listing P and Q and all the possible cases of true and false that can be created with two statements. All right, so I'm going to write P and Q here. And then I'm going to list all the possible cases, all the possible combinations of true and false that P and Q could take. All right. So P, we always start with T. All right. True. The first case is when both statements are true. Then the next one is first one true. Next F is false. Then we have FT, false, true. And then we have false, false. All right. So there are 4 cases, 4 combinations of true and false that can be created from 2 statements P and Q, from 2 sentences P and Q. So the rule is that if you are working with 2 statements, then 2 simple statements, then you will have 2 to the power n combinations, 2 to the power n cases. So we have 2 statements, so 2 to the power 2 is 4. So we have 4 cases here. All right, now in the subsequent columns, we will use the symbols given, and then that will lead us through the steps to getting the final truth table, the final answers. All right, so we have a tilde here, and I'm going to write the tilde. All right, so we have the first tilde outside the brackets, and then we have the brackets. And within the brackets, we have a not. So there I'm going to write not Q. And then we have the or symbol. And then we have the P. All right. And not Q or P is surrounded by brackets. And I'm going to keep the brackets in my table as well to remind me that I must work with the bracket first, with whatever is inside the brackets, and then I have to go and see what is there outside. Right? Now, within the brackets, we always start with negation. All right, we start with negation and then we deal with the conjunction and the disjunction, whatever there may be. So not Q, what that means is we have to take all the Q true and falses and negate them. So if it's true, the negation of that will be false. If it's false, then the negation of that will be true. So I'm going to take all these TF, TF and switch them, negate them. So T is going to be F, and I'm going to write that under the negation for Q. So T is going to be an F, F is going to be a T. All right, then this T is going to be an F, so F, and this F is going to be a T. So that's all the negation. That's all the negation. Now, then we have the OR P. All right, so let's list all the P values here. Now, P doesn't need to be negated, so we can just write our T, T, F, F. All right, so for the P values inside the brackets, all right, you just list the values, the combinations of true and falses for P. All right, just copy whatever is here because we are not negating the P. But we have to now calculate or find what the disjunction does. Now, or recall that for the or, the only case where it will end up being a false is if both the statements are false. As long as one is a true, the result will be a true. All right, so what I'm going to do is I'm going to use a different color now. I'm going to do this F and T. F and T will be a T. So I'm going to write the T here. All right. Then we have T and T. That's going to be a T also, true. F and F, all right, in the OR statement, the only time when we get an F is when both the statements are F. So in this case, F, F, false, false leads to a false. It's a false. And then the last one is TF, so that should be a true. All right, so we completed everything within the brackets. Now we have to negate that, we have to go to whatever is outside the brackets. So we have the negation, the not symbol here. So what do we negate? We negate the result of not Q or P, which we listed under the OR symbol. All right. So T, T, F, T, when we negate the T, this becomes an F. So let's write F. I'm going to write F here. Then this T is going to be an F. Then the third one is an F, correct? Over here within brackets. Under the V, we have an F. So that will become a T. That will become a T. And finally, we have a T. That will become an F. All right, so the final answer is what we have here under the not symbol, the first negation, the first not symbol. So the final result of this statement is going to be F, F, T, F. So here is the solution that they have provided to us. So let's see if that matches with the way we worked it out. All right, and the results we got. So it's going to come up step by step. So first step should be to negate all the Q values. So if it was a true, then not Q would be a false. If it was a false, not Q would be a true. So let's see if that's the case. All right, so the step one, yes, this is the step one, and then they go one by one. So the true is changed to false, the false should be changed to true, all right, and the true should be changed to false, and false should be changed to true, all right. And then in the next step, it should be the P, the true and false related to P, which is just copying whatever we have in the first column, right? So you should see a T, T, F, F come up. So let's see that T, T, F, and F. All right. And then we will have to go uh, and work on the or, all right, the disjunction. So FT should be a T. So let's see. This is step 3, all right? So these numbers below are just telling us the steps, the way we are proceeding. First step was not Q, then it was to list all the P, and then evaluate or work on the or, all right? That's the third step, so that should be T, T, F, T, all right? And finally, the fourth step should be the negation that's outside. So that's step 4 here, all right? That's step 4. So let's see what happens. Negating this T here. Negating this T here should give a false. Negating this T gives another false. Negating this F should become a T, all right? And then this T should be an F. Okay, so the answers match exactly what we got for the solution. All right. We will now learn how to construct a truth table using an alternative method. The statement given here is different from the one that we worked before. It says not P and not Q. However, I'm going to first evaluate it using the previous method, and then we will work the same statement using the alternative method, and we should get the same results using both methods. All right. So in the previous method, this is how we worked on it. We first listed all the cases for the two statements with the combinations of true and falses. So TT was the first case, then we had TF, then we had FT, and finally we had FF, correct? And then we had our not P and not Q. We went on to creating the table for this entire statement. But we always work on the negation first. So we first have to negate all our P values. So that would be make the T's an F and the F's and T's. So F becomes T, T. All right. And then we have to work on the second negation of all the Q values. So that would be F, T, F, T. And then we have to evaluate the AND construct. So remember in the AND table, uh, both the statements should be true for it to be a true, for it to be assessed as true. If even one is a false, the result is a false for the entire statement. All right. So let's see over here we have FF, so we should get an F. All right. The next one is FT. Even if one is a false, it is marked as a false. And then we have TF, so that is a false too. And lastly, we have a TT, so that is the only one which will be a T, and this is our final result. All right, so the final result is somewhere in the middle. All right, we would write the values under the and the last step, wherever that occurred. The alternative method is going one by one, so we would, and let me separate this a little bit. So with the alternative method, we have not P, and then we are going to also write not Q without the and in between them. All right, so not P values are, what are they? FFTT, so let's just copy them, FFTT. And then the not Q values are FTFT. So let's write those, FT, FT. And the last column would be not P and not Q. All right, so we would have FF, BF, and then we would have FT, an F, TF is an F, and TT is a T. All right, so it's just that the final result is in the last column using the alternative method, versus in the previous method we decided to write it below the AND construct, which appeared somewhere in the middle of the table. All right. So we will now look at the solution that they have provided to us. So in the first step, they write the P and the Q and all the cases that go with it. So construct a truth table with 4 cases. So first 2 columns remain the same, which is list all your P cases and all your Q cases. But from the next column is where we'll do the work. All right. So now let's look at the third and the fourth columns. They do the same thing as what we did when we worked using the alternate method. They negated the P values, all right, and then all the Q values, right? So it says add columns for not P and not Q for the third and the fourth columns. So all the P values T, T, F, F now becomes F, F, T, T. They get reversed because of the negation. And the same thing happens to the Q values. When we negate it, they get reversed. So T becomes F, F becomes T, T becomes F, F becomes T. And then we add a column for not P and not Q. So let's see that appear. All right, so here's the column, and then we evaluate it and put the results here. All right, so it says use columns not P and not Q. So these 2 columns to find not P and not Q. So FF is F, correct? FT, for the AND construct, even if one is a false, the result is a false. So FT is F, TF is F, and TT is F. And the final answer is FFFT. So that appears now in the last column. So the final answer using the alternate method appears in the last column, whereas using the previous column, it appeared somewhere in between not P and not Q, wherever the AND construct was placed. All right. Now finally, we will learn a way of determining the truth value of a compound statement without constructing a truth table. All right, so here it says determine the truth value for each simple statement. That's the first step. So we have to break up our compound statement into 2 or more simple statements, as many as there may be in the compound statement. Then using these truth values, determine the truth value of the compound statement. So let's see how it's going to work. We have the statement given to us, 1 million is greater than or equal to 1 billion. All right, so what this means is this has 2 statements in it. All right, we can look at it as 2 separate statements. The first one is 1 million is greater than 1 billion. All right, so let me write that. It says here 1 million. The first statement is 1 million is greater than a billion, greater than 1 billion, whereas the other one is 1 million is equal, right? That's the other one. 1 million is equal to 1 billion. And it's connected by an OR. Okay, so let's see how we are going to process this to come up with the truth value. So here's the solution coming up one by one. So first it says, let P be 1 million is greater than 1 billion. So that's how we had constructed the first statement, and then the second statement, which is denoted by Q, is 1 million is equal to 1 billion. All right, so what do we do next? It says here the compound statement can be expressed as P or Q, correct? Because these are connected by an or. So 1 million is either greater than 1 billion or 1 million is equal to 1 billion. All right. So over here, look at this. We have P or Q. So is 1 million, try to think. Let's write it down here. It says P. Well, let me write it up there because I think more information is going to come up below. So P or Q. So what did P say? P said 1 million is greater than 1 billion. That's not correct. It's not true. 1 million is not greater than 1 billion. So that's going to be marked as false. And then the or statement. The next one, Q, says 1 million is equal to 1 billion, which is false too. 1 million is not equal to 1 billion. So that's going to be false as well. And false or false, when both are false in an or statement, the result is false, correct? The result is false. So that's how they work out here. The compound statement can be expressed as P or Q. Both P and Q are false, which we saw by reading the two statements. Substitute F for P and F for 1 and evaluate the statement. So P or Q, so F or F, which gives an F, which results in an F. Now over here, I think this is an error in a typo really. It's F for P and F for Q. That's what it should be. This should be a Q, all right? Anyway, so they work it out here. P or Q, F or F results in an F in a disjunction. So that is the final answer. So that's a way of working or determining the truth value of a compound statement without creating a full-fledged truth table. All right. Let's go through a final example. This time we have to resolve the truth value of a compound statement with three statements, three simple statements in it. All right. So it says here determine the truth value for each simple statement. Then using these truth values, determine the truth value of the compound statement. So we're going to work this out here first, and then in the next few slides, we will run through the solution as provided. All right. So let's read through the compound statement. It says Angelina Jolie is an actress, or Zac Efron is a janitor. And then a comma, but Johnny Depp is not a plumber. So let's break this up into three statements, and we'll name the first one P, which is P is Angelina Jolie. All right, Angelina Jolie is an actress. That's P. I'll mark that as P. Then we have Q, which says Zac Efron is a janitor. All right, Zac Efron is a janitor. That's the second statement, second simple statement. And then finally we have, but Johnny Depp is not a plumber. Now, even though this has a not, when you assign the statement, all right, when you just break it up, you have to take it without the negation, without the not. So we have to write it as Johnny Depp is a plumber. All right. You take out the negation from it when you assign or when you set up the statement. All right. So we'll call that R, statement R. And now we'll put it together based on put it together in symbolic form using the information from this compound statement. So it says Angelina Jolie is an actress, or, so we have the or word here which refers to the disjunction. So how do we write that? That would be P or symbol and then Q, correct? And then because of this comma, remember previously we said if there's a comma between statements, then we have to surround it with brackets. So P or Q, and then this but here, it is a conjunction. All right, even though we've learned that and is a conjunction, but nevertheless, these are also conjunctions. So conjunctions have the and symbol. So I'm going to write the and symbol, and it's are, but over here in the sentence here, it says Johnny Depp is not a plumber. So we have to take that into account when we are setting up the statement in symbolic form. All right. So, and you have to say not are. You have to use the tilde to negate are. So now we have to resolve this. We start by looking into the brackets first. We have to work on the brackets first. So P, which is Angelina Jolie is an actress, is a true statement. So I'm going to write T under this P. All right. And then the or symbol. And then Q says Zac Efron is a janitor, which he's not. He's an actor. So this is a false statement, right? This was true, this was false, and Johnny Depp is a plumber is false as well. So for Q, I'm going to mark that as false. And then we have the and symbol, and then R is a false, correct? R is a false. So not R will be a true, correct? Not F. So this is what it's going to be, not F. So T or R, F in the next part, in the next step, T or F resolves to true, correct? In an or statement, as long as one of the statements is a true, the result is a true, correct? So I'm going to write here T. Sorry about that. So T, this resolves to a T. And then we have the and symbol, and not F is a T. So T and T is what we end up with. And we know that if both statements are true, then in the and statement, it resolves to a T. It resolves to a T. So the final result of this entire statement, which says Angelina Jolie is an actress or Zac Efron is a janitor, but Johnny Depp is not a plumber, is a true statement. So here we have the solution. They've first broken the compound statement down to three parts. The first one saying P is representing Angelina Jolie is an actress, Q represents Zac Efron is a janitor, and R represents Johnny Depp is a plumber. All right, so the statement can be written in symbolic form as P or Q, and then we have the and then not R. And P or Q is surrounded by brackets because there was a comma next to the first two, or after the first two statements. All right, so now let's go to the next slide and see how they resolve this. So P is Angelina Jolie is an actress, and that's a true statement, so we are going to mark that as T. And then Zac Efron is a janitor, that's going to be marked as false, and Johnny Depp is a plumber is going to be false as well. All right, so now the statement is P or Q and not R. So P is true, Q is false, and R is false. Since R is false, therefore not R is true, correct? So that part is going to be a true, and then we have to resolve P or Q. But P or Q, when we resolve that, true or false. Let's write it out like this, all right? So we have P or Q, right? P or Q. So that's true or false, resolves to a true, correct? It resolves to a true. And then we have and not are. So not are resolves to a true, correct? R is false, R is F, so not R will resolve to a true, correct? So so T and T will resolve to a T, all right? So here's the final workout of the solution. It says the statement is P or Q and not R. So P is true, Q is false, and not R is true. And given that P or Q is and not R gives us T or F and T. So T or F gives us a true, and then not R gives us a true as well. And because of the and conjunction, the final resolution is a T. All right. So for this compound statement, the truth value was a true.